Okay, so for you guys that have not received it yet, please shoot me a DM with your email address you would have registered with, and I'll help you guys all troubleshoot one by one.
See, and your link should have came. I think you made this last night, so it should have came yesterday from no reply at CoreStack.
I know some of you guys might have registered later yesterday or early this morning. If you did, you haven't received an invite link because you were not on my initial roster.
All right, Trey is working through all those, so we'll give it about one more minute, and then we will kick it off. All righty. Well, I think that's enough time to let everybody kind of trickle in. Don't want to take up too much time waiting. So with that, we will get started. Like we said, if you did not get a registration link, again, it should have come from no reply at corestack.com. Please just shoot us, the hosts and panelists, a message, saying that you didn't get the link and put your email in there, and Trey will get you sorted out. So with that, hi everybody. Welcome to the Hunting Through the SIEM workshop that we'll be putting on today. Thanks everyone for hopping on. So it'll be a little bit of slides, a bunch of lab time. We'll get to go into our lab and deploy a threat with SCYTHE. We'll get to hop into Splunk and hunt through the SIEM for a little bit of it. If anybody has any questions or comments or anything at any time, please throw them in the chat. I think we can also unmute you if you have a comment or something that you want to say. That's also totally great and fine. We want this to be as interactive as possible. So yeah, any comments or anything like that, please feel free to say them whenever you have them. But with that, over to the obligatory who am I's. I am Tyler Casey. I am the lead detection engineer and the deputy of SCYTHE Labs over here at SCYTHE. I've been doing DCO, which is defensive cyber operations, for about 10 years now. Currently, I run the blue or the defensive side of our purple team engagements, and I'm responsible for putting out a lot of the threat emulations and the detections and things like that that come along with our threats. Before I came over to SCYTHE, I was on a CPT, which is a cyber protection team, where we deployed internationally for incident response and targeted threat hunting operations. And I have my socials on there. If anybody would like to connect, I'd love to chat.
Hey, all, that is me. I am Trey. As you can see, that face looks like my face. I am the lead of SCYTHE Labs over here in professional services. I am kind of the primary red counterpart to Tyler's blue. My background is, what did we come up with the number now? Is what, 17 years at
Yeah,
least? Something like that? Yeah, like 17
yeah.
years
For you, it's like 17.
in IT and cybersecurity as a whole. That's doing everything from basic IT network infrastructure stuff to defensive and offensive cyber operations. Me and Tyler actually came from one of the same teams way back when. Now I've done a lot of red teaming. I help with threat hunting, analysis. I've done a lot of consulting. I've built content on Hack the Box Academy, if you guys have ever played on that platform. And I am here. If you like alphabet soup, there's some of the ones that I currently hold. And if you want to connect with me, my socials are at the bottom.
For sure. And then I see in the chat asking if we'll get a participation cert or CEUs. Yes, I'll have a CEU that'll be at the end of the lab that you can download and then submit to whomever. And then the link that we're talking about should be, so our lab is based in CoreStack. So CoreStack should send you the link to the lab environment, so you can go in and have your own lab environment. And the session, this one I think is already being recorded. So it'll be posted to our YouTube channel at SCYTHE here in probably just a few days. All right. With that, just some table of contents is again to overlay what we're going to be talking about. So we'll be going through hunting through the SIEM methodologies and its iterative processes. We'll go over some Splunk queries and functionality. We'll deploy some threats via SCYTHE, and then we're going to hunt for those adversarial behaviors, and then we'll wrap it all up with some documentation and a way to report our findings. This workshop is only 3 hours, so sometimes we don't quite get to the reporting piece of it, where you guys get that hands-on opportunity to do the report. But the main chunk of this, is going to be performing the threat hunting. And while the workshop is only 3 hours, we have the lab extended to 4 hours. So if you want to practice on your own, there's an additional hour that's built into the lab. All right. So the first up, I guess, before we get into actually performing threat hunting, we'll just go over some threat hunting 101 and talk about kind of what it is. Is anybody that's here, is anyone here a threat hunter or has done some kind of threat hunting operations in the past? Or aspires to do some kind of threat hunting operations? All right. Me one day? Okay, for sure. I say, well, hopefully this will be a great Kickstarter to kind of get you started on it. And we'll see. But yeah, if anyone's got any threat hunting experience, I'd be interested to hear about it. But with that, we'll go on to what is threat hunting. So threat hunting at the most basic level is just actively looking for the bad guy, right? You want to actively look for malicious activity or malicious indicators, right? Trying to find the bad, and actively is really the main word here. We're not going to wait on we're not always going to wait on alerts to come in or for things to get triggered or things like that. We want to actively be in our environment trying to find adversarial behavior, right? And so there's two main approaches to threat hunting. There is reactive and proactive. Reactive is when you are triggered by alerts or anomalies that are detected by automated systems, right? So that's if you get an alert from the SOC or you get an alert from your EDR, whatever it is, saying that, hey, this malicious activity has happened, this alert has triggered, we need you to go in and investigate it, right? You're reacting to something that has happened. Or proactive, which is my favorite kind of threat hunting, is a hypothesis-driven hunt where you're looking for unknown or maybe stealthier threats. So proactive threat hunting is when you receive some kind of CTI or you have a thought that, hey, an adversary is performing these actions in their campaigns. I'm going to proactively go out there and see if I can find what this adversary is doing in my environment, right? You have a hypothesis that you think this group is, I don't know, let's say doing ransomware on your is performing ransomware in their campaigns, and included in that, they do some lateral movement and some things like that. Your hypothesis is that they're going to perform this on your machines, and you're essentially just going to hunt for them like they already did these actions. One caveat for proactive threat hunting is that just because you are proactively threat hunting doesn't necessarily mean that you're going to find any kind of malicious activity, because that activity might not have happened yet, right? You're not reacting to an alert or something like that. You are going into your environment before all of that, or maybe in lieu of alerting to try to find if this has happened. So more often than not, when you perform proactive threat hunting, you're probably not going to find anything because you can't find something that hasn't happened yet, right? That's okay. There's still tons of benefits to proactive threat hunting. One, that at this point in time, in this snapshot in time, those adversarial actions have not happened on your endpoint yet, right? Because you've formed the hypothesis, you've done the threat hunt, you don't have any indicators of compromise or anything that you did find that was anomalous. You ran down and you said that this is good now, right? So you have that, you have a little bit of a peace of mind for that snapshot in time. But also proactively threat hunting helps you in other ways that might not seem as important to threat hunting, but I would say are very important to threat hunting, and that is knowing your environment, right? Knowing your environment could mean what services are normal, what processes are normal, user login times, common software, scheduled tasks, services, all kinds of things like that. As you proactively threat hunt through your environment, you're going to identify these things, right? You're going to see that PowerShell scripts are running. You're going to see that ps-exec is normal in your environment or not normal in your environment, right? Different things like that. Be able to identify, um, if there's a new service that's installed or anything like that. So outside of just looking for adversarial behavior, proactively threat hunting will give you more of a lay of the land into your environment, which is really, I mean, having a baseline is really integral to performing high fidelity threat hunts later on in the future. So don't be discouraged if you are threat hunting proactively and you don't find anything. That's totally fine. Just make sure that you go through your hypothesis all the way. You'll still get quite a bit out of it. All right, and then on to the importance of threat hunting. Threat hunting is human driven. It will help reduce the impact in the event of an incident. It'll strengthen your incident response time. It'll reduce your dwell time, and it'll help you fill gaps, right? So by actively threat hunting in your environment, you're going to, again, know what is normal and what's not normal. The quicker you're able to identify what is abnormal or not normal, the quicker you'll be able to essentially suss out if it really is malicious adversary behavior or it's just your IT guy that's running some admin scripts or something like that, right? The more that you threat hunt, the quicker you'll be able to identify what is wrong, and that'll lead to your dwell time being lower. Which means that you'll be able to identify that behavior a lot faster. It'll strengthen your instant response because you won't have a bunch of false positive logs or as many false positive logs kind of weighing you down that you have to go through. You'll be able to quickly identify like, nope, that's normal, this is normal, and things like that. And I think one of the most important parts is that it will help you to fill gaps. And by fill gaps, I mean the visibility that you have from a defensive standpoint, right? So if your hypothesis is that you're looking for, again, like that lateral movement, right? Maybe lateral movement via RDP or something like that, and you're threat hunting for it, you don't have any RDP logs, you're not able to tell any kind of lateral movement or anything like that, that's a gap, right? You're like, oh, I thought I had visibility into this tactic or technique. I don't. So now I can go in on the other side, add in some additional controls, change some configurations or things like that, and then fill that gap, re-go through your threat hunt, and then you can prove I am able to see these logs. There's just no activity happening or whatever it is, right? So that's a really big one, and that's why we hit on that threat hunting is an iterative process that will have you continually going back into it as you make updates, as you fill gaps, as new information becomes relevant, right? Excuse me. All right, and then over to methodologies. There's three main categories that I'll break threat hunting down into as far as methodologies go. That's intelligence-based, behavioral-based, and entity-based. So intelligence-based is just like it sounds. It comes from intelligence. Your CTI team, your cyber threat intelligence team gives you some information. Like I said, maybe they see that a threat actor that's inside of your industry vertical is performing some kind of actions. They're concerned about it. They want you to take that information that they've gathered, that they've ascertained. They want you to take it, go into your environment, and see if that's happening in your environment, right? So that's intelligence based. The next is behavioral based. So that's when you utilize anomalies to identify or hunt on potential threats. So this would be more of a reactive one, like you see a change to the endpoint. So maybe you see a new service is created on a user machine that isn't installed anywhere else, right? That's behavior that has changed. So now you're going to threat hunt off of that. A little more reactive, probably not alert based, but if you see that there's a change in your system or something like that, then you hunt off the behaviors. And then the last one is entity based. So that is really just keeping a close eye on your critical systems, right? Things that will be most likely targets to an adversary. So for most places, that would be, domain controllers. Those are really important, obviously. Maybe file servers, if you have a bunch of proprietary information on there, maybe your CEO's laptop, something like that. Things that are really important that you really just want to keep an extra close eye on. And that is really just based off of, you have to keep operations up and you have to keep your boss happy, right? So you want to focus on things that are critical because oftentimes in a huge environment, it's difficult to give each endpoint kind of that tender love and care that maybe you would give these extra important systems to, so they get their own category, right? And then some core principles. I only got like 2 more slides of talking about threat hunting, and then we'll get into some stuff. So some core principles of threat hunting, again, is that threat hunting is an iterative process driven by hypothesis and facts, right? So your hypothesis is what you think is going to happen, and then you use the facts, which is the data from the logs, right? You want the logs to tell the story of what's happening. You don't want to try to cram your logs into your hypothesis to tell your story. You want to make sure that it is based in fact, that it is using those logs and that information that you found through the threat hunt to prove your or disprove your hypothesis, right? You want to be based in fact. And it is TTP focused. So we want to hunt for adversaries TTPs. TTPs are tactics, techniques, and procedures. So that is what the adversary is likely going to do on your endpoint, right? We're talking about lateral movement. We're talking about using PS exec. We're, being evasive, things like that, performing ransomware, different pieces like that. We want to hunt for the adversary's TTPs. We want to make sure that we include that in our hypothesis. And then iterative, again, is just so you continually go through it. If you threat hunt today for that lateral movement piece we're talking about and you don't see it, tomorrow it could happen, right? Maybe it just hasn't happened yet. So you want to, obviously you don't want to do the same threat hunt every day. That's probably not going to make a lot of sense. But maybe once a quarter, you revisit a previous threat hunt or something like that, whatever fits into your battle rhythm. You want to make sure that you incorporate it and that you check again, right? Maybe you've received some new logs, maybe there's some new intelligence, maybe there's something, some signal, some driver that has preemptive or that prompts you to go back in and search, or maybe you just do it every few months, maybe once a quarter or something like that. Excuse me. One other piece that I had on here, that when we was talking about the TTPs, what we would kind of hit on or frame our hunts when we were on the cyber protection team is we would basically phrase it. Sorry about that. We would have it where you want to hunt for your most likely course of action and your most dangerous course of action. So the most likely course of action is what is an adversary most likely to do on your environment, right? This is probably gathered from your intelligence briefings and things like that. What is an adversary most likely to do? What are they seen doing all the time, right? They have some kind of a phishing campaign that comes in, a user clicks on the link, it runs an executable. That executable does enumeration, and then it attempts to lap move to a machine, and then it ransomwares the machine, right? Something like that. So the most likely course of action that's kind of here on what you want to threat hunt for, like based off your CTI, based off the facts that this is what they're likely to do. And then the most dangerous course of action, which is more for your environment, right? So the most dangerous course of action could be, well, it's probably ransomware. That's a pretty bad one to have. But maybe your most dangerous course of action is they're going to blow up a power plant, right? Something crazy like that, or they're going to turn off, they're going to supercharge the generator or have the generator run over time to make some kind of fault or something like that. So you have your most likely course of action here based off your facts, based off that CTI, that intelligence that you have. Then you have your most dangerous course of action up here, which is really just for your organization. What are you the most concerned with? What's most important to you? So those two places and maybe a happy middle are great places to start your threat hunting hypothesis, because you can cover what is most dangerous to you and what is most likely going to happen from an adversary perspective. Just like to throw those out there. I don't know if anybody else that does threat hunting has anything kind of similar to that for how they get theirs started. I'd be curious if you do. All right, and then into the threat hunting process. So it is essentially 5 steps, right? So the first step, we're going to have our hypothesis, which is just what are we trying to see? What do we think is going to happen? What are we trying to validate, right? And then we get into the data collection piece of it. That's where we're going to gather telemetry from our log sources. Are we going to investigate endpoint issues? Do we need network data, proxy logs, email logs? Whatever that is, we need to make sure that we have those logs, because if you don't have logs, you're going to have a very difficult time in proving or showing what happened, right? If you have no logs, you're going to have no threat hunt, right? You've got to have something to look at, some kind of fact, some kind of logs for you to go through. Which brings us into our next step, which is to analyze. the data. So now you have all your log sources, you have all of the collection done. Now you want to look for abnormalities, right? You want to look for malicious activity, or you want to look for, just things that are different, things that are abnormal, right? Anything you find during this phase, we're not going to do a super hunt on it yet. We're just trying to identify these strange things, these things that are different. So anything we find, we'll throw into the investigate process, which is next. And then with that, so we're in the investigate piece of it. So an anomaly was found. So now you need to dive in and figure out, why is this anomalous? How did this get here? What is it doing? Where is it going? Things like that. Did it communicate to anything else? Did it spawn another process? Is it just an admin script that's on the endpoint? Are you getting failed user logons because it's a script from years ago that user is gone, those creds don't work, and no one just ever deleted it? See that all the time. So some things like that. So you just wanted to start investigating, see what it's doing, see what else it's doing, any surrounding events. And that's where you're going to start to piece together kind of the full picture of the threat hunt, of what this abnormal or malicious activity is. And then the last step, just like anything else, is to refine. So you need to document your findings, report any actual incidents up, educate your team on any potential gaps you found, how you can fix them. Just kind of run down with the team how the threat hunt went, what you did, what you found, things like that, ways to improve in the future. So yeah, the threat hunting process in and of itself, not super complicated. It'll get more complicated when you start actually doing it, when you get into the investigation piece of it. But really, you just want to identify what's happening, or have your hypothesis, what you think is going to happen or what is already happening. You want to collect all the logs that you're going to need to make sure that you have them all. You're going to look for that anomalous or malicious behavior, investigate them, and then create whatever deliverables that you need. That's in the refined piece. Any documentation, reporting, things like that, change requests, anything like that, and then just make sure that the people that need to have them have them. Is there any questions on kind of like the history of threat hunting, or the threat hunting process that anybody has? Everything kind of making sense? All right, cool. That. All right, so into some Kickstarters. So you don't have to jump into threat hunting on your own. There are a lot of resources out there, definitely more than just these two that I have up on the screen, but these are the two that I most commonly use. And the first of those is Sigma. So Sigma is an open sourced structured format for writing detections. It's written in YAML. Sigma HQ houses a couple thousand community detections for us to utilize. It's super great. We have another slide on it here in a minute that gets more into it. But basically, they're pre-written rules you can go in and use to kind of get started on your threat hunt, or to identify some kind of activity. And then the second is Splunk security content, which is a repo of analytic stories and security guides. More information on it here. This is kind of what it looks like. So they have analytic stories, which are kind of like plain text or layman ways to explain different activity that's happening and how they would go and find them. They have different detections that are written in Splunk, obviously, and then some playbooks, which are kind of like, if you see this activity, you should do this thing next, or like, this is the recovery step for that. It's a really great resource. We're going to be looking at it here in a minute. And then back to Sigma. So I already kind of talked about it. It's just a place that, or it's a format to write rules, but it's housed on Sigma HQ. But how Sigma works is essentially just what you see in this picture here. You have a rule, your detection rule.yaml, whatever you have it called. You feed that rule into a converter, such as Sig converter, and then once you put it into that, it will translate that rule into whatever SIEM or EDR, essentially any security tool that has a query bar, it can translate it to. So Elastic, Splunk, Rapid7, KQL, anything like that. So that way you can write all of your detections in one spot, in one language, and then it can be utilized by the community regardless of what tool you're utilizing. Has anyone used Sigma before? SIGMAC. Okay. Okay, cool. All right. So with that, we will get into our first lab. In this lab, we're not going to be inside the lab environment. We're just going to get started on just kind of familiarizing yourself with Sigma and the Splunk security content. So we'll take about 10 minutes and just go through these sites, just kind of look through and see if you're able to find, just get familiar with it. And then we will meet back up here in a few minutes. After this, we will be getting into, I'll kind of walk you through a hunt based off some activity, and then we'll get into into the labs for most of the time that we have left. With that, so I'll give it about 5 minutes, see how everyone's doing, and then actually think, Trey, I think after the 5 minutes, maybe we'll have everyone hop onto Core Stack and just get everything started, so that way, because it can take a little bit to come up. So
Yeah, agreed. And
yeah.
just as a one more time, does anyone else need a fix or a resend link for their core stack invite? If you do, just shoot me a message or send it down to host and panelist and we will get you sorted.
Sure. So we'll see everybody here in about 5 minutes or so, see how everyone's doing. Yeah. Yeah. Hey, Jacqueline, I just saw your comment in there. For that we're just kind of looking through the rules and things like that for now. We're going to hop into the core stack lab here in a second. This was just to kind of get you familiar with Sigma and the Splunk detections that they have in place. But I'll just kind of quickly click through some stuff on here and then show you on Core Stack how we're going to get started on it. Yeah, so in the Sigma HQ, just go to Sigma, and then they have their rules in here. They have some, broken down threat hunting, emerging threats, forensics, things like that. But rules to give you kind of your best bet, have it broken down, by operating system, by category, things like that. But really the best way to use it is just to kind of search for what you're looking for up here. So maybe you're looking for 7-zip, something like that. And then it'll show you all of the rules that correspond to what you're looking for. So if you're looking for like 7-zip utilized to create a password extraction, or utilized for this Conti 7-zip or things like that, it's really the easiest way to hunt through it. Or if you're looking by like specific T code, like 1059, which is just like process execution, like running something through PowerShell, something like that. Maybe not the best T code to look up, but you look it up by T code as well. And then that'll give you all of the corresponding detections to that T code. It's just a great way to kind of get you started if you're looking for something in particular. It's really useful. We'll get more into Sigma and things like that later on. We just have this as just kind of a way to see what it's talking about. And then over to research Splunk. Go back to the main page. So inside of here, so like I said, they have detections, analytic stories, and playbooks. Playbooks are like the automated response to go through, the automated response to go through, like if something happens, do this other thing. Analytic stories are more like use cases talking about what's going on. So maybe like this termite ransomware. So a whole description, why it matters, different detections associated with it, what data sources you could find these, like what these detections utilize. So those data sources, that gets into your log collection or that data collection we were talking about before, and just some references. So just kind of a, in layman's terms, way to go through what this story, what this campaign is doing. And then the last one is just going through and looking at detections, which in there are the same thing, right? If you want to find Tor traffic or whatever it is, you can click on those. It'll have the rule or the detection, the search query already labeled out. And that way you're able to just kind of quickly get started on that. With that, let's go over to Core Stack. So everybody should, again, have received a link. If you're having any problems, let me know. I think I saw someone in there that Splunk wasn't coming up. The reason for that is there currently is not a way to set the boot order of our VMs. So if your machine comes up before the domain controller comes up, then DNS gets broken, right? DNS,
Surprise, surprise.
yeah, that's what's breaking everything, right? Always. There should be a fix on that here soon, but there isn't one yet. So if you did launch everything over here, which to get to it, you just click on Systems, click this drop down, and click Start. If you ran those, you connected to the Unicorn host box, which is what we're going to be doing everything through. So connect to the Unicorn box. When it comes up, it'll be grayed out until the system is all the way up. So we'll have that go through. Give it a second to pop up. Yeah, well, mine is loading. So yeah, if you were not able to get Splunk to come up, or maybe if SCYTHE didn't come up, if that one turned on first, whichever one it is, you could just stop SCYTHE, stop Splunk, and then reset them and then start them. And then that way it should communicate with the domain controller like normal. And then everything should be loaded. So let's see. Ever. Okay. We have mine that came up here. Yeah, so you can go ahead and start all of the systems now on there. Just hit start. We're going to use them here in the next lab. So just go ahead and get them started now. It might auto fix itself with the DNS issue. If not, when we get to it, we'll just stop and start the machines that aren't working. Yeah, again, it's because of the boot order, and then that messes up with DNS, kind of the problem of everything, right? It's always DNS. it's not DNS, then it's AWS is broken, or GCP was broken the other day. All right. So yeah, so again, with this last little lab was just to get a taste of, Sigma and this Splunk security content. And then once you have your link to CoreStack, please go into it, go to systems, and we'll just start all of the machines on there. We'll talk more about CoreStack before this next lab. Everybody good so far? Andrew Gustafson. That name looks familiar. Sweet. Okay, everybody seems like they're good. Fantastic. Alrighty, then let's go on. Okay, so we again talked about kind of the theory, kind of the maybe the not so fun part of it. Now we'll talk about SIEMs. Specifically, we'll talk about Splunk, and just kind of what it is, how to use it a little bit, and then we'll get into threat hunting. All right, so Splunk. Does anyone have experience inside of SIEMs, like using Splunk, using Elastic? Sentinel, anything like that? Splunk and a little bit of Elastic. Yeah, that's probably about as much Elastic as you need, right? We're team Splunk over here. I'm just kidding. Elastic's a great product that people like. Okay, so kind of a mixed bag. That's fine. We're gonna go through all of it, kind of soup to nuts here, so you'll be able to do it even if you don't have any experience. No big deal. So I was just curious. So, a SIEM. What is a SIEM? A SIEM is a log aggregator that will provide you with a centralized view of what is happening, right? So we highly recommend, couldn't recommend any higher for defenders to utilize a SIEM and have their pertinent logs forwarded and ingested by your SIEM, right? Your SIEM, again, is going to provide you with that centralized location to hunt across your environment. You can also set up some automated alerts or for it to perform certain actions based off alerts. That's called a SOAR. But so you could set up an alert. We have a little joke in here that you'll never forget to buy milk. You could set up an alert that monitors your milk level in your fridge.log, right? And if your milk level gets below 20% in fridge.log, then you could have your actions, put in a DoorDash order to order you some more milk or something like that, right? Which sounds kind of funny, but places like Domino's will utilize SIEMs or organizations will utilize SIEMs to see if people are working past a certain time. And if they are working past a certain time, it'll automatically send out an order to Domino's and have them bring the order back to you, like different things like that. You can use it for a lot of things outside of threat hunting. For threat hunting itself, you would have an alert, that would monitor for, let's say, something simple like who am I usage, right? If someone runs who am I, you want it to perform these certain steps, right? You want to get an email, you want to quarantine the machine, you want your EDR to triage it. Obviously, you don't for who am I, but just as an example, you can set it up for based off the results you get, go out and perform these actions, right? And I know I hit on that you get a centralized location to hunt across for your environment. A little more on that. So if you don't have your logs forwarded into a SIEM, where do you think you have to go to threat hunt on those logs? You have to go to the endpoint itself, right? Or everywhere. You got to go everywhere. You got to go to 15 different browsers or links to get to your EDR, to get a CrowdStrike, to get to your proxy logs, to get to your email security gateway, your firewall, whatever it is, right? Or if you're looking for host logs for endpoint logs, you have to go to your endpoint to actually query those logs. If your more than one machine is affected, that's making it a lot more difficult. It's essentially impossible. It's trying to find a needle in a needle stack is what they say, right? It's almost impossible, right? You want all of your logs in one spot as much as possible so you're able to hunt off of one thing and correlate those logs to each other, right? So if you have your firewall.log and you have your endpoint logs, maybe you want to correlate those times together, right? You see that something was that PowerShell was spawned at 12:42, right? You want to see, did that make a network connection out that was blocked by my firewall at 12:43? You want to see those logs back to back without having to go back and forth. That's really the benefit of the SIEM. It's all in one spot, right? All right. So kind of into the SIEM, we talked about logs and things like that. You need to know what logs and log sources you have ingested into your SIEM. And more on that, you need to know what host they're coming from. If you don't know what logs you have, what data you have, or what hosts are ingesting those logs, when you go to actually, like if you are in a real incident response or something like that, if you have to really go into that and that's the first time you're seeing what logs you have, you're going to be in bad shape, right? You need to know what logs you have ahead of time so you know what you can hunt on, or again, fill those gaps we talked about earlier. If you don't have this log that you think you have, you need to go in and rectify that situation, right? So how we do that, just some three fairly simple searches we have here. We're looking in the metadata to pull out our source types, sources, and host. So your sources are like the exact log where it's coming from, and your source types are just kind of like ways to describe those, essentially, right? Sometimes they look the same, like with the Windows event logs and things like that, but your source types could be like firewall or something like that, and then your source would be firewall.log, right? It's going to look different for every environment and every tool that you have ingested. And then host will just pull out the host or the computer names of where you are ingesting all your logs from. Should also pull your like your firewall names and things like that based off of what you have being ingested. It's a lot quicker to run it with those metadata queries, much faster. So I recommend, if you are going to look and see what logs you have over a large amount of time, you run these metadata commands that just take a few seconds instead of probably a few minutes. And so, in our lab environment, we are ingesting Sysmon logs, endpoint security logs, and application logs. So we don't have any network information in our lab environment, but it'll be fine. We'll be mostly focused on logs on the endpoint. And then to data organizing, there's two main ways that we're going to organize the data that we see. That's going to be either via the table or the stats command. So table is going to pull out just the fields that you want to see, right? So instead of getting, I don't know if you guys have ever looked inside of like your Windows event log, it's just a huge wall of text, right? A huge wall of information that is very difficult to parse through and read, especially correlate with anything else. A lot of the time, you'll know what fields you want to see, which fields are important to you. You can just table those out. It makes it a lot easier to read. And we'll see some proof of that when we get into the lab here in a little bit. Yeah, SIEMs work by essentially you look for specific values inside of those fields. So in the example we have up here, we're looking for event code 1, which is process creation in Sysmon, and the parent image, which is also known as the parent process of PowerShell or CMD. So searching on these values without organizing them, you're going to get a lot of information back that it's again going to be difficult to read. So to kind of fix that, what we'll do is we'll table out those fields. So this example, we just want to see parent image and command line. And in that, it's just, again, makes it a lot easier to see the values that we're trying to see without just having these giant walls of text. And again, we will practically do this in the lab environment. I know that it's one thing to talk about it. And then the next way is with stats. So in table, as you saw here, it's got a bunch of lines, right? We have 17 lines in there. That's some of them kind of show the same information. So in parent image, we see that CMD is listed out 5 times or so, and PowerShell dot or PowerShell underscore ISE is listed out 6 or 7 times, something like that. Maybe we want to group those together a little more effectively, a little more efficiently, right? So to do that, where in table, it'll have a new row for each event that occurs. Utilizing the stats command, it'll help group those together, right? So in this example, we have that same search up top, but now instead of tabling out the command line and parent image, we want to see the values of command line by parent image. So how that works is the Parent image is just PowerShell and CMD, and every command line argument that was spawned by that parent image is going to be grouped next to it. So it's just a lot easier and a lot cleaner to be able to see exactly what is going on. And then stats has more than just values. I like values because it kind of works as deduping what's going on, so you don't get duplicates inside of it. But you could also use count, which will provide you a numerical number. So maybe you want a stats count by command line for some reason. It'll tell you there was 1, 2, 3, 4, 7 or so command line arguments by PowerShell, 5 or so command line arguments by CMD. And you can use sum, which will add up fields values. That's not really useful in this example. That's more for like looking for data exfiltration or something like that. You could maybe do a sum of like the bytes received or the bytes sent or something like that to see if large chunks of data have left your environment. Again, we'll do this in the lab here in a minute. All right, so into our first hands-on bit of lab. So we're going to familiarize ourselves with Core Stack. There's a video in there that's a few minutes long that Trey recorded that just kind of talks about all the different pieces of Core Stack. It's a lot easier to have you guys watch it on your own than me try to watch it through Zoom and everything gets all distorted. So we have that, and then we're going to deploy some threats via SCYTHE. The reason this is, obviously Trey and I work for SCYTHE. It's not a SCYTHE demo or promo or anything like that. We just need SCYTHE to send that signal, send that malicious activity to the endpoints, so then we can hunt on it. The easiest way for us to do that is with SCYTHE. And then we'll get into our first hunt with Splunk. So we'll look for some simple stuff in Splunk just to get everyone kind of familiar with it. I think we might even do a Sigma rule up there at the top. So with that, we'll do all of, we will do all of the intro. So intro, Core Stack, all this familiarization stuff, and then we will go all the way through Sigma and Splunk familiarization. So this should just have a video for you guys to watch. This just tells you a little bit about SCYTHE. Not super important for what we're, you can feel free to skip over that, check it out later. And then we'll create a campaign that we'll deploy. Please follow all of the steps on there. And then we will deploy an existing threat. We'll deploy lockbit v3 on the endpoint as well. And then we're going to deploy these campaigns on the Unicorn host box itself. So if you get any pop-up saying it's unsafe or keep or anything, just go ahead and accept it. It's going to be totally fine, but everything we'll be doing will be inside of this Unicorn host. And then once you deploy those two threats and get a little familiar with it, we'll get in, we'll perform our first hunt. We have the queries down there with a little more information. We'll see a Sigma rule, we'll translate it, we'll throw that back into Splunk, just kind of prove that it works. So with that, we've got about 20, 30 minutes for this. So I will set a timer for 20 minutes. And then at that, I will check in and see how everybody is doing. If anything comes up before then, please just throw it in the chat and we'll see if we're able to help you out. Are there any questions on anything? All right. Nothing hurt. Okay. Sounds good. All right. Yes, we'll do about 20 minutes. Have you guys jump in. This is also your lab time, so if you want to continue ahead, like the lab should be able to walk you through basically what we're going to be doing. So if you want to go ahead, that's fine. Just please don't ask any questions on something we won't be doing for another hour. Yeah. So see you guys in about 19 minutes.
Okay. Hey guys, I just wanted to show you guys this again real fast. As you're going through this workshop, for you guys to do the hunt piece and the follow-on actions in previous sections, so anything down here in Splunk familiarization, hunt, or reporting, we're going to need to generate that thread signal first, and we're doing that through SCYTHE. So these first three sections here for SCYTHE familiarization, creating the campaign and deploying it, you guys need to actually take these actions. If you do not run through these sections and generate that telemetry, none of the previous Splunk queries or searches or anything like that are going to work. So we've done this so that one, you can get used to generating that threat signal and kind of doing it on your own, utilizing a Purple Team platform, but also to ensure that you're not having to set any kind of weird, crazy date time queries or searches while you're looking for this threat behavior. So again, if you guys, before you dig any further, we need to do these first three sections for scythe familiarization, create campaign, and deploying an existing threat. Once you do these, everything else should fall right in line and be okay. Is everyone doing okay up to this point?
Right, it seems like everyone is getting to the part where they are deploying the campaign. So I'm just going to kind of talk through. I'm going to do the first part over here and talk through it. If you're getting everything to work, feel free to ignore me. Just doing it in case anyone is having any issues getting the campaigns to execute. So up first, we on the Unicorn host. Again, everything that we do in this lab should be on the Unicorn host. You don't need to interact with any of the other VMs on there. And we'll be deploying all of the campaigns and threat steps on the Unicorn host box itself. We'll go in, open up Chrome, go to the SCYTHE bookmark, go over here, click Create Campaign, call this First Campaign. You can leave all of the default set because we're on a Windows machine. We're going to communicate over HTTPS. And then from there, going to load some modules. So the modules are, we refer to them as kind of like building blocks or Lego blocks, right? They're utilized to help the campaign and perform certain actions for you. So like crypt will encrypt files, downloader will download files, executables, things like that. We talk more about it in the SCYTHE familiarization piece in the lab manual if you want to learn some more about that. But we'll do ARP, we'll do print screen. You could also just type it up there if you don't want to search for it, and then run. So once we have our modules loaded over here, then we'll go down to execute action. Mine was already clicked for the show more, but you can see some of the defaults that they have on there. So we're going to do a print screen of the desktop. We're going to run ARP, and we're going to run Who Am I? And then from there, we're going to scroll back up to the sequence templates. Sequence templates up there, and then add attack techniques. Here, these are just different atomic tests that we have set up for different tactics and techniques, kind of already pre-configured, so you don't have to do them on your own. So you can search either by T code or by the name of what you're trying to do. Search by the T code here. So you want system timed discovery. Click system time discovery up there at the top. Configure. Localhost is fine. We're going to leave all the defaults. Add step, which will add in these two steps, which will perform that system time discovery actions for us. So in that, we'll go ahead and save it. You don't have to save it to get it to deploy, but we'll do it like this just in case there are any issues and we need to modify it. So we'll save threat, and then we'll go ahead and create the campaign. That'll take us to our campaign view here. Check this box, click download. I'm going to download this as a DLL. Change the entry point function. So by default, absolute client main is the entry point function of our DLLs. You can change this to any function points that are inside of the DLL itself, but the two that we mainly use are absolute client main or this DLL register server. And we'll download, probably get some prompts, no big deal. We'll download the files anyway. Open it up. And then inside of there, we're going to rename this file to dar.dll. The reason for that is just to make it easier to find inside of Splunk. It will execute just fine with whatever name you have already, but this is just, again, just to make it easier and make it so you can just copy and paste these out. So then we'll open command prompt right there. And then from there, we will run DLL32, which will call dar.dll, which is our campaign that we just made, and feed it that entry point here. So we'll press enter on that. That should get it kicked off. And then back on the SCYTHE campaign view, we can see we get a dropdown. That means that our implant has checked in, and we now have a shell on Unicorn host. So in a few seconds, there we go. We can see that the loaders are going. This is just going to load all the modules. In a few seconds, we'll see the actual campaign steps being ran. We'll give that a second to go. And in a sec. So it's running ARP. You see when the commands are ran, or when these procedures, these steps are ran. Up here, you can see the request, which is to do the print screen of the desktop. You can see here, same with ARP and run, who am I, all the stuff like that. And then in the lab, we tell you can go ahead and in this corner, click on shell and give it a shutdown. That'll terminate the campaign. I'm going to leave mine open in case I have to do some stuff later. But if you did turn it off, totally fine. And then the next one on there is to create the lockbit threat. So we'll call this one H1. Defaults are fine. Going to add existing threat. L for lockbit. Lockbit v3 is the one that we want to run here. Add steps. That'll put all of our steps we've created over there. Sorry that the view is kind of messed up. I have it on a split screen on my computer. Hopefully you're able to see it all right. On there, and I like to keep the artifacts on disk, so I'm just going to delete my cleanup steps here. You don't have to. I just like to. I like to leave them. That will create this campaign. There, similar to the other one, we'll go ahead and download this. This is going to be an exe. I'm going to download unverified file. An unverified exe from the internet. What could go wrong, right? And then we'll rename it to H1. The last time we did this course, people named it h1.exe.exe, which messed up some of the, the searches we have later on. So H1, it'll keep that exe extension on it by default, and then we'll right click and then just run it as administrator. Nope, we don't care about smart screens. We're not trying to be sneaky. So let's go ahead and execute it. And then we'll give it a second, make sure we get a check-in. We get a check-in, and then that will execute. So what we're trying to do, or the point of these two campaigns, one, the first campaign we're going to utilize for this, our first hunting through Splunk, and then the H1 or the Lockbit ransomware emulation is what we will be hunting for in the actual hunting through the SIEM, going all the way through it. Is everyone able to get these to execute and run? Okay, if any of the bookmarks don't work, okay, everybody's getting through. If any of the bookmarks didn't work when you clicked on either Splunk or SCYTHE, sometimes they'll take a few minutes to come up all the way. But if they don't come up, maybe after 10 minutes or so, what you're going to want to do is go over on this one on systems and go to SCYTHE, stop it, wait for it to stop, reset it, and then start it again. Again, the issue with why some of them were coming up like that is because the boot order for this, you can't set what the boot order is. So if something comes up before the domain controller, it just messes up the DNS. So you just have to restart it. All right, getting some that the dar.dll isn't working. For that, did you rename the executable or the DLL to dar.dll? Okay. And then when you made the dar.dll, did you go back? Did you change the entry point from absolute client main to the DLL register server? This part here. Okay. And then you're saying you're not getting a check-in? Oh, so saying that the first campaign is running as a normal user, not as admin? Or if you could paste the error that you're getting, problem starting dar.dll. Yeah, I think so. Let me see.
Hi, can you hear me?
Yes.
Yeah, so the problem that I'm facing is my PowerShell is working as administrator. It is not going like normal. So the command will not work if it is under administrator, right? For running the dart.dll.
Hmm.
So
It
it's
should
Um,
still function. Here,
yeah, it
I
should
can.
work.
how will I make it like normal? Because it's now running under administration. Because this command is not for the administration, right? Because
Yeah,
it's a normal PowerShell, right?
it's fine if it runs as admin. It might be starting your prompt as admin just because you're the user we're logged in is an administrator, so that could be why it's opening the prompt as an admin. That's no big deal. It shouldn't matter.
But why is it not working? The command is not at all working. I don't know why. It's just really strange.
Here,
Yeah,
I
for sure.
can. Tyler, I'll take it over and I can hop in the lab environment and help her.
Okay. Say Trey is gonna hop into your lab machine and take a look at it. Yeah.
Okay, okay.
Emily, it says the specified module cannot be found. That is a new one. Can you try to, are you, Emily, and yours, are you setting the run DLL 32? Like, does it look similar to what mine looks like? And then Russell, if the smart screen comes up, you should be able, I'll re-execute this one. If the smart screen comes up, you should be able to just click around it. Okay, so your path ends at administrator. It could be um, it's probably just one directory too low. So if you open up, you can either do a CD to downloads, or if you open the file explorer here and click on the URL bar and then type CMD, it'll open a command prompt inside of that directory. But I think maybe you're just one directory too low. Like if you do a dir, you should be able to see it on there. Okay, sweet. Me and then Russell with yours. Yeah, if you let me just make an actually I'll download this campaign as an exe. So when you download it, if you get it blocked, just click the dots, download unverified file, and then open it up here, and then right click, run as administrator. Oh, I already clicked around the smart screen, so it might not come back up again. Okay, so that worked fantastic for Emily, and then Russell. Okay, so are you saying that you were able to get it to run? You just had to go through PowerShell or command prompt? Okay, fantastic. Sorry about that, everybody. It's Windows trying to keep you safe. All right, so everybody should have those in there now for those to work. If you have any other problems with it, please let us know, and we will continue to troubleshoot. But I'm going to go on to. Oh, John, you probably just have to refresh it over there. Sometimes it doesn't refresh on its own. All right, where this will be the most cumbersome piece of the whole should be the most cumbersome piece of the whole lab, just making sure we get everything run correctly. All right, so while you guys are doing that, I'll show just kind of the first hunt here. So now we'll navigate over to Splunk. In here, it should auto log you in, but if not, the credentials are over there. So in here first, we'll get into the first search, which is just looking for the process of who am I running with the parent image of run DLL32, which we see pop up here. So this is what I was saying before, in looking at the logs without grouping them together in any way makes it very difficult to kind of read and parse or correlate really anything that's happening. It's just so much information. But here you can see all of the field values, see process created, creates who am I, from downloads, administrator, just a ton of information. We see was launched by run DLL32, and this is a command line which should match the command line that we ran in our terminal just a few minutes ago. Knowing that, so also inside of Splunk, we're not into any of the grouping or anything yet, but on the left we can see it has a bunch of interesting fields. So if you do have a search, maybe you're not really sure what's inside of it, you can click around on the fields on the left, like you see the hashes of what was ran, what index it's in, the image, which is the process, parent image, which is the parent process, and so on and so forth. And then getting into kind of, maybe I should change it from beautify your output, because we are beautifying it. We are going to group it in a different way. So utilizing table, we're going to just table out time, computer name, parent image, parent command line, and command line. As far as the process creation events, when you're hunting through those, this is typically what I like to table out. I think it's really got pretty much all of the information that you need in here, or enough where you could later kind of pivot to it, or pivot off of this information, like the parent image or something like that, to get some more info out of it. JD, are you saying that you don't have any of the logs in Splunk? And then Hajar, what documentation are you looking for? Okay, sweet. Okay, I must have gotten confused by the other one, the guide. Are you talking about the manual, the course manual? The course manual should be able to see inside of the course stack link you have, and then just chapters, and that should take you to where we are as far as the manual or the guide is. We don't have like a PDF that we send out. Okay, and then Trey has got Jacqueline. Okay, who was everybody able to get through this, or most everybody able to get through this part? Just like that initial, making sure that we have all of our logs, or that we have logs, we're able to reach all the sites, our threats were deployed, and we can see some information off of them. All right, John's going through it still. Okay, so getting through to the bookmark after resetting, no problem. Okay. Trey is gonna, sorry to throw you under the bus there, Trey. Trey is gonna help troubleshoot some of this, the issues that you guys are having. I'm gonna press on here in a second just to make sure that we are able to get through all the hunting for it. If the who am I stuff doesn't work, that is okay. Like if you're having issues with that. The main one is just that the lockbit v3 threat runs, because that's what we're going to use for the actual hunting through it. So if inside of Scythe, if your H1 hasn't gone through with at least some of the yeah, that's perfect. If your H1 doesn't look something like that, where it's gone through about 40 times, it's got four errors, that's totally fine. But if you're having an issue on that, please just know. Campaign is showing as pending. Yeah, so if the campaign is pending in the campaign view, you need to go to your downloads and right click on the H1 and then run as administrator, and then that will get it to check in. Stand up. Get my stuff set back up. Okay. Alrighty. So like I said, I'm going to continue on just so we're able to keep track kind of with the time. Trey is able to hop in. Trey is able to hop into your lab environment and kind of be remote assistance as you need it. But he's doing some other ones now, so I might just take a second. Okay. Oh yeah, one thing. Yeah, so Rudy, if it signs you in as admin, that's fine. In Splunk, it should auto sign you in. If it says admin, that's totally fine. There's only one account on there, so as long as it logs you in, that is totally fine. And then for the part about the campaign pending, what you're going to want to do for that is, you have the campaign. Make sure you download the campaign as an exe. Once you do that, it will go into your downloads directory. It'll go into your downloads directory. From inside of your downloads directory, if it is not named to H1, if you haven't already renamed it, just rename it to H1 and then right click on it and run as administrator. And then if you get any smart screen issues or anything like that, just allow it to run through. Okay, perfect. And then Jaleisha having issue administrator. Oh, Jaleisha, your is because it doesn't have the run DLL 32 in front of it. So you'll need to do run DLL 32.exe dar.dll and then DLL register server. So because it's not a typical executable, it needs to have run DLL 32 in front of it. So that way it is able to it essentially has to call run DLL 32 to launch the DLL. It won't just run it if you give it the just the name of it. Okay. Alrighty. Into hunting. Again, if you have any issues, throw them in the chat and we will fix them as soon as we can. Hopefully, it seems like everybody is pretty much on the same page. Yeah. Okay. So in this, we're going to kind of walk through a hunt. We're going to walk through an intelligence space hunt, and then from that, we're going to switch over back into our lab and hunt on our own. Or it'll be it's called a guided hunt, which is also known as a safari, which is what we'll be doing here in just a few minutes. But into our hunt. So our first hunt scenario is going to be an intelligence-based hunt. So if you remember from before, it said that there are a few different types of hunting. There is the intelligence-based, there is behavior-based, and there is entity-based. This will just be an intelligence-based hunt. So our intelligence cell, our CTI team, our intel team, whatever you want to call them, they have a high confidence that Volt Typhoon, which is a Chinese threat actor, that Volt Typhoon has targeted your organization and has provided you with their observed TTPs. So the intelligence report, the CTI, that they give us is going to be our launch pad or jump pad for our hypothesis and hunt plan. So first up, we need to form our hypothesis. So in our, so based off the CTI, we're able to hypothesize that Volt Typhoon will attempt to obtain credentials via either obtaining ntds.dit from the domain controller. It's going to run VSS admin to create shadow copies, and it is likely going to run ntdsutil to copy ntds.dit. What we have over here on the right is the actual CTI that we sourced from CISA. Got the link down there at the bottom if you want to check it out on your own. But in this, we see that Volt Typhoon is going to try to get credentials via these means. So now we need to go ahead and, excuse me, all that talking gets all that air put up in there. So given this CTI, this is what we think that they're going to do is obtain credentials via these means. So we need to either create or curate some detection rules that are going to help us hit on these TTPs. Before we get into that, can anyone say why they would be looking in ntds.dit or why ntds.dit is important? Ashes, okay, yeah. Crown jewel of Active Directory. Okay, yeah, you guys know what we're talking about here. That's what I'm talking about. System hives, yeah, it's got juicy information in there, right? Your ntds.dit it's got everything, right? It's got passwords in there, it's got the SAM file in there, it's got registry hives in there, it's got a ton of information in there that would be valuable to an adversary. It also kind of one step back, one abstraction layer back. Also, it is hard to copy ntds.dit without triggering some kind of alerts. It's got a ton of information in there that people know it's the crown jewel. Like somebody said in the chat, like Emily said it in the chat, it's the crown jewel, right? It's got everything in there. So to kind of sidestep that, one way that Volt Typhoon has tried to do that is to create a shadow copy, and then they pull the shadow copy, which is essentially a backup, pull that out, and then offline pull out ntds.dit because people don't look at backups quite as much. So anyway, so yeah, we know this. We need to go in. We need to find some TTPs. We need to find some rules. We need to start hunting on it. So for this instance, we'll just head over to Sigma's GitHub page and find a rule to match on our hypothesis. So in that, we went to Sigma's GitHub page and we essentially just looked for the word ntds.dit and searched for all of the files inside of there. So in that, we're able to find this query here, which is looking for activity related to ntds.dit domain hash retrieval. So this rule is great because if you look under the command line arguments, you see that it references deleting shadows, creating shadow copies, trying to copy out ntds.dit. It's got multiple 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got 9 different ways that they hunt for this. And in our query, it's going to look for all of those. We don't need to run 9 different searches. It's going to look for all 9 of those command line arguments in our one search. And kind of the proof of that here, excuse me, is you can go in. Oh, this is a bad image. This is an example image. Sorry about that, but it'll be the same. We'll take our Sigma rule that we have. We'll paste it on the left. We'll select Splunk as our backend, and then on the right in the query is where our query is going to be. Right, so it'll auto translate our query from. Excuse me. It'll auto translate our query from Sigma into Splunk for us. Once you have that, you just copy the query on the right. You go back into Splunk and you paste the actual query in there. I'll need to change that image here before the next course of this. But you paste it in there and you're able to see that you have some bits of information in there, right? So hunting through the SIEM is, not to sound cheesy, but is both kind of a science and an art to it. So just because you have that alert, you translated that alert or that rule, that detection, that query, and you post it in there and you get results back, that doesn't necessarily mean that that malicious behavior is happening, right? In this example, seeing some things in there like copying out ntds.dit, creating shadow copies, like that stuff is pretty anomalous and is more than likely malicious. But just because you get a hit on a rule or a hit on a search doesn't mean to like sound the APT fire alarm and alert everybody, raise the let all of China know that you're here, right? You still need to do some investigation. You can't just take this, say we found the bad guy, and then keep going on. So you want to make sure that you take some notes of anomalous or malicious activity. So at the end, once you do the investigation and refine piece, you can piece together all that's happening. If you don't document everything kind of as you see it, you will likely get pigeonholed into what you're looking for, and you're going to miss stuff, right? So just continue to document, write stuff down, ask yourself questions, and continue to hunt through it. Kind of off my little soapbox there for a second. So with that being said, what do we see here? What is returned in our search? What is returned in our search, and does anything here warrant an additional investigation? What do you guys think? See, hopefully you're able to see it all right, but you see like PowerShell is running, PowerShell is spawned, it's running out of the admin desktop, and then the command line arguments are creating shadow copies, they're copying out ntds.dit to somewhere. Oh, Trey, is you over there?
Hey, Tyler.
Yeah,
So that system time rule
yeah.
that you reference in Sigma role inspection, that repo no longer exists. So the defer report decided to delete their entire repository and just contribute everything they create directly to the Sigma HQ project.
Oh,
That's on
that's
us. They just did that recently, so we'll change the link in the
yeah.
manual to match Sigma HQ.
Okay, that's hilarious. Okay, yeah, we will update that, but you should be able, if you do want it, you should be able to download it um, straight from the page, and then we have that Sigma rule just typed out there as well. But we'll update that. Update that. Thank you for whoever saw that. Yeah, and you see, yeah. So in there, we see some pretty anomalous stuff again that we see here. Like this great shadow is weird, and then copying of ntds.dit, and then trying again to copying out to the temp directory. That's pretty anomalous, right? That's something that probably is going to warrant some additional investigation. So I'm going to say that yes, we ran this, we had our hypothesis, we found a rule that we thought would match on it, we converted the rule, we ran it, we got some pretty anomalous results back. I think it's probably worth it to dig in and see what else we're able to find, right? See if there's any other activity going on. All right, and then so how are we going to do that? We are going to investigate. So I think that there is probably, like I said, there's enough there for us to continue our investigation for it to go through. When we find, back it up, when I find something that I think is anomalous or suspicious or maybe even malicious, anything like that, I like to kind of take a step back and start my investigation around that event, around that time period, right? Or around like picking something off of like that process or parent image or something like that, something to pivot off of it. So in that, we're going to go in and just kind of we'll do this in the lab, but we have selected our time to be around when that anomalous activity that we discovered a second ago, our time right here, the 1648. We'll change our last 24 time picker to be around a minute or so of that 1648 to be able to see what other events are occurring inside of that window, right? So in there, I just change the time, I take out our rule, and I change what we're looking for from that specific rule to just event code 1. Event code 1 is process creation. So I want to see what processes were made around this point in time, trying to get to kind of what started everything, right? So looking at the logs we have here, does anyone have what they think, what the executable name was that started all of this? Like that kicked everything off. And this is separate from what we did in the lab. You'll get to hunting through the lab on your own in about 5 slides or so. Yep. Okay. So we see PowerShell.exe for sure. So we see that it was ran by PowerShell. The one that I'm looking for, so we see the parent image of PowerShell here spawns the image of excuse me, of hunt.exe, and then we see hunt.exe then being called as the parent image to these suspicious command line arguments that we see afterwards, right? So we see hunt.exe is the parent image, or is the image up here that's called by PowerShell, and then we see about 2 lines down that it's now the parent image that's calling CMD, which is calling net, which is calling PowerShell and running all of these kind of anomalous command line activities, these host enumeration commands we have over on the right, like who am I, net start, get net neighbor, things like that. But it's all spawned from that hunt.exe. So that's probably a good thing to write down and take a note of, so we know that it's doing things that are malicious. It's spawning these additional activities that we don't like. It's running these strange command line arguments. We want to see more of what that's doing. And then just a point on this too, I know we talked about it a second ago, but you want to, as you're going through, document constantly. If you can't document constantly, you're going to forget kind of what you were looking at and why it's important. Screenshots are also a great way to do it. So taking a screenshot, kind of like what we have here of your query, so you have your query to rerun later on, is great. And then maybe like a sentence or two on exactly what you see, why you think it's suspicious, things like that. But here we see hunt.exe is probably the thing that we need to take a look at. So now we'll go in, we'll change up our query a bit to now we're back out of that 30-second or 1-minute time window. We're back in the last 24 hours or whatever the time window is that you think is right, maybe 4 hours if 24 hours is too much. But anyway, so we changed the time window, and now we're looking specifically for the parent image of hunt.exe because we think that is probably at least abnormal, right? So we need to investigate that a little more and see what it's doing. So in that, we have it grouped together with stats and table to be able to see the parent image, and the values of their command line itself. So we see hunt has spawned PowerShell.exe and CMD.exe, and we see these commands that it ran afterwards. So we see on the top one that it's looking at the security log for event code 4624, which is successful logon. I'll ask you guys a question about that here in a second. It does get attack net neighbor, which is kind of like test connection and ARP kind of all in one. We see that they're trying to copy the ntds.dit to the temp directory, creating shadow copies, which we've seen, the net start, who am I, and they're running a curl command trying to curl out, it looks like trying to curl out ntds.dit, which they moved to temp. They're trying to curl that out to file.io. So some still pretty, say pretty close to malicious, about ready to fire off that alarm and say that, yeah, we have some things that are outside of abnormal that are likely malicious that we need to continue to investigate. The one that I do, so this is from our Vault Typhoon threat that we have. The one piece that I think is really interesting here is Vault Typhoon, when they run that get event log security instance 4624, they're doing that to try to ascertain what your valid users are when they've last logged in. So instead of running like get tac local user, get tac domain user, anything like that, instead of doing that, which is probably going to trigger something because that's abnormal for a lot of people to do, they're instead going to look in your event log and see what valid successful logons you've had on that machine. So that'll tell them what users are valid, when's the last time they logged on, and if they logged on from a remote host or network share, RDP, something like that, it'll give them that information as well. And most people don't care what's happening inside of your event log as long as it's not cleared, right? So it's a great way to kind of get around detections for like valid user enumeration or something like that. Anyway, so we see in here that hunt has spawned these additional commands. We've written those commands down. I think that file.io possible exfil is probably something that you want to investigate here in a little bit. But so we know that, we know some more information. And then still focusing on that parent image or that parent process of hunt.exe. Now I know what processes it created, what command line arguments it ran. I want to know what network connections it has, who it's reaching out to. Are there any, is it a known C2? Are there some domains maybe we can block? Things like that. Who is it talking to? We know what it did on the endpoint. Now, what is it doing out there in the world? So in there, we are just looking for event code 22 or 3. 22 is for DNS requests and 3 is for network connections inside of Sysmon. So in that, we see that it's that hunt.exe, our probably malicious campaign, is reaching out to training stage unicorn croft.io, as well as 3.128, 209, 240. So in that, I think it's probably fair to say that these are the C2 domains that hunt.exe is utilizing to communicate back and forth with, right? And then from that, this is just a very quick hunt. And from that, we kind of go over what do we know? So from just that quick hunt, we know that PowerShell spawned hunt.exe from the campaigns directory inside of that admin profile. We see after hunt.exe was executed, it spawned some discovery commands to include who am I, netstart, get netneighbor, etc., etc. After those discovery commands were ran, it attempted to create a shadow copy of the C drive, and then it copied out the ntds.dit from that shadow copy to the temp directory. We see at some point the hunt.exe has queried the event log for event ID 4624, which again is trying to ascertain those valid local or those valid users and where they came from. And we know that at some point, curl, it had utilized curl to reach out to file.io, likely trying to exfil that ntds.dit file out into the world, so then they could utilize it later on for whatever means, right? And then we also see that it had 2 network connections, or maybe 1 network connection seen 2 different ways, out to that training.stage and out to that 3.128 IP address. Did anybody see anything else that we missed on there? I know we kind of quickly went through it. And then, well, people put it on that. I'll put in there kind of what do we think about this, right? So again, in threat hunting, you have that hypothesis. You're testing out. So our hypothesis came from that CTI from our team that Bolt Typhoon is known to pull ntds.dit files to try to do credential dumping, credential harvesting later on. So knowing that information, we curated a query that we got from Sigma that is like, hey, these are all the different ways that we've observed people trying to interact with ntds.dit. We ran that command, we got some hits. We continued to investigate all of these anomalous things. We eventually found hunt.exe is the parent process of everything. So now we're kind of at the end. We have these individual kind of silos. We painted a bit of a picture here into what was going on, but they're still kind of siloed. So what do we think altogether of like what is happening, right? We see that these commands were ran with admin privileges. We know that it was at least they thought they had admin privileges, and we know that because one, the directory that it had launched from is the administrator directory. So that's a little bit of a cue that it was likely ran by an administrator. And then it created a shadow copy, which is something that normal users can't do, right? You have to be an admin or system to create a shadow copy. So we know that they're admin. They got to admin somehow, right? Who knows? We don't know how yet, but we know that they got to admin somehow. And then we see that they likely, like if everything here worked like the adversary tried to, we see the command line arguments. We don't have proof yet that it worked, that it was successful in any way. We just know that those command line arguments were ran, but let's assume that it was successful. We've seen that the adversary was able to exfiltrate ntds.dit, which they will likely try to crack offline on whatever endpoint that they have to gather some more credentials, right? And we saw too that the adversary utilized that get net neighbor and that event code 4624 24, which will give you the other machines on the network as well. So it's likely that they'll utilize both the information they get from ntds.dit as well as the accompanying hosts that they were able to find out through the getNet neighbor, that they will use the credentials to now try to laterally move over to those endpoints, right? You guys say that that's fair, that that's probably what's going to happen? Or anybody have any other ideas? Yep, time to change the golden ticket. Every user has MFA on. Hashers are cracked offline. That's what I'm talking about. That's Russell. I couldn't agree more. I think that those are great points. That's definitely something that they should do. Then that they're going to try to utilize the hash to move laterally. 100% agree. I had some other ones on there for some other things that we should do. So first of all, escalate the incident, right? I think that we have enough information here to show that malicious activity is happening, right? This is beyond, most likely beyond abnormal. This is malicious activity done by a skillful threat actor to laterally move across your environment for what means we don't know yet, right? So you want to, oh, sorry about that. You want to escalate the incident as soon as possible. If you're able to, you're going to probably want to isolate this infected host, right? Because if it's doing all this malicious stuff, probably want to isolate it so it can't, they can't use this machine as the jump host essentially onto all of these other machines in your environment. So if you're able to isolate it, you should isolate it. And then from there, you want to expand that hunt out. So you want to see, so we know the two C2 domains, or at least those two indicators of compromise as far as C2 goes. We know what those are. So now we can go back in the SIEM, take out that host that we've been hunting on, expand it to all the hosts, and see is any other host reaching out to these IP addresses or to this domain. If they are, need to be investigated. Possibly just isolate them immediately, so then you can be, so it doesn't spread it any further, right? Another one too is see if anyone is reaching out with curl, see if any get the hash of hunt.exe, see if that exists anywhere else in the environment, things like that, right? You want to take what you know, escalate it up, and then kind of spread out and see, am I affected anywhere else? Because if they did the same thing on 10 other hosts and you isolate and take care of this one, but you don't take care of all the other ones, then essentially you've done nothing, right? They still have 9 other valid hosts that they're able to utilize and crawl against, right? What is going on with my slider here? Oh, sorry about that. Yeah, so we have our hunt piece is over. We kind of went over the story of what it was doing, of what's going on. We have a bunch of indicators now we can pass off. We can make rules off these things, and we can continue to kind of hunt out. So into the refined point of it, we could see, is that initial detection we had useful? Should we start to employ it for future use? Should we set it up as an alert in case something like this happens again? We want to be alerted immediately. Did we create any new detections as we were threat hunting through everything? Anything like that, you want to reuse the stuff that you made. If you don't, it's not that it's useless, but you'll just be recreating the wheel and re-going through everything. You want to use the stuff that you made, right? Were there any false positives you can exclude? I don't think in this example there was, because it was pretty targeted. We didn't have any other noise going on or anything like that. But if you saw that, like in these queries, you were always getting something back from, I don't know, let's say Splunk or something, the Splunk agent that's running, maybe you can exclude some files or exclude some directories or users or things like that. Maybe in the hunt we saw that there was this was all an admin script that was ran that's totally normal, something that an administrator does and is fine. Maybe there's a way that we could exclude this admin script from being a part of our hunt or our query later on, right? And then last, do we have any gaps in visibility that are hindering our ability to identify any kind of specific behaviors? I would say in this, we don't have any network logs. So maybe like, hey, we've identified this on the endpoint, but we don't have any firewall logs. Like we need firewall logs ingested into our SIEM to be able to prove or disprove that this activity was allowed to leave the network, right? So we saw that curl command to file.io. Now we need to check the firewall logs or the proxy logs to make sure if it was successful or if it was blocked by your firewall, right? If you have, your defense in depth, which is multiple layers of defenses, maybe it wasn't stopped by your EDR on the host, but maybe it was stopped by your proxy log. Maybe it was stopped by Blue Coat or something like that. So you want to go in, kind of have a sit down after everything has cooled off and go through your hunt, see what you can use, see what you can add to, see what you can expand on, so you're better prepared for the next time. This is just an easy wins dashboard that we have. We have this inside of Splunk also. I can show you guys when we get into the lab. These are just some places where if I don't know where to start, I like to look here, right? So suspicious command prompt or PowerShell parent images, setting the run key, running curl on running curl via PowerShell or CMD I want to know about, and I want to know about suspicious process creation, which to me is any process that's created outside of like program data or system 32. I want to know about it, right? Your publics, your download directory, your temp directories, shared drives, things like that. If it's not in a typically installed directory, I want to know about it. And then I think I have like two more points before I got two more points, and then we're going to get into hunting on our own. So the next point I want to focus on is state-based detections. This is a piece we always kind of harp on. I think is really, really important, and the best way to do threat hunting is you don't want to focus just on keyword searches. And what I mean by that is, so we saw in our example that they're utilizing ntds.dit to do stuff, right? The best way to look for it isn't to look for like just quote star ntds star end quote and then search across everything, right? You want to focus on the state-based detections, so things being created or manipulated or moved, things that an adversary can't hide, right? So in that nts.dit example, it would probably a better way to look at it would maybe be seeing if any images or DLLs, any images tried to interact with ntds.dit with that file itself. That would let you know that hunt.exe interacted with that system. But in the example here, it really, I think, spells it out better than the ntds.dit example. So in the top left, with the white background, is our SCYTHE command that we ran. This is not a part of what we're doing. This is separate, just as an example. But we can see that we're registering a scheduled task called Microsoft_Xbox U, right? And in the top right over here, you see we have inside of the command line, we have a bunch of just keyword searches. So we're looking for new scheduled task, schedule task at, different things like that, which we see those commands, that new scheduled task or register or scheduled task, we see that over there on the left, but we don't see anything populating. It doesn't make any sense why we're looking at the keyword searches. It's because we ran that command via upshell, which is unmanaged PowerShell, which is just a different way of calling PowerShell. So it's not logged the same. It's essentially the same as running something in memory. When you run it in memory, it's not logged the same because those command line arguments aren't written to disk. They only exist in memory, so you can't see them by just looking at those keyword searches. But in this example, when you create a scheduled task, that scheduled task or that command will create a file inside of these different tasks directories, the Windows, System32, and SysWow64 tasks directories. It will make that file there. So this scheduled task, even though you can't see it in the top right by doing command line searches, you can see it by focusing on the state-based detections of that file being made. So a long-winded way to say it's better to focus on what the adversary cannot change or what is very, very difficult for them to change. It is fairly trivial to run things in memory or utilize something like PowerPick or Upshell to run unmanaged PowerShell. That's not difficult for an adversary to do once they have a check-in, but for them to not have the file right in this directory is just not possible. It has to be written somewhere. So if you focus on what has to happen, your detections will be higher fidelity, and just a better way to hunt for malicious activity, right? And then kind of the same thing here with the keyword detections. This was just to show, like, from an attacker's standpoint on the right, you could get the who am I information from echoing out the user domain and username, or by running who am I, or by running sysinfo, or by running, just pulling environment var, all kinds of ways. But if you just search for who am I over there on the left, you're not going to see that echo user domain and username. So the point of this slide is just to kind of show you, like, just because you look for something one way, there's a multiple different ways for an adversary to do it. So just iteratively, again, go through the different ways that an adversary could do it, and that'll really give you the best chance to identifying this abnormal or malicious behavior. All right, sweet. After a long time of me talking, and that now brings us into our hunt itself, which will basically bring us to the end of it. Let me get my chapters. Okay, so we're gonna go all the way through the hunt. All the way through the hunt piece of it. So it starts off, we get an alert from the SOC that the Windows event logs have been cleared on the unicorn box. You see, the time of this doesn't match up because the time should just be like a couple hours ago. But we see that the event logs were cleared, and then the rest of the lab will kind of just guided walk you through how to hunt all the way through from this alert kind of to the end. So that'll take us pretty much, right up until the end. So I'll put 30 minutes on the timer just to see how everybody is doing with it. And then at about 30 minutes, I'll see where everyone's at, maybe demo through some of them real quick, and then that'll pretty much wrap us up. So if you have Trey to drop for a second, so if you have any issues or something, please throw it into the chat. But as long as your campaigns were able to execute, everything should show up. But if something doesn't work, please let me know and I will pop in. Yeah, I've got 29 minutes or so. I'll check in, see how everyone's doing. But yeah, if something comes up before then, please let me know. All right. See you guys in a minute. Yeah, hey Jacqueline, I just saw your comment in there. If when let me share my screen. If when you run this query here, refresh so the page is right. Um, if you run the query here for the event codes, if you still have the time picker to just those 30 seconds, these events more than likely happened outside of that. So you just need to change the time picker to, I did 4 hours, 4 hours should be fine. You could do 24 hours if you would like to. This is a lab environment, so you could really make it kind of as expansive as you want to. But if you change it to 4 hours or expand it to 24, you should see the rest of the event codes in there. Yeah, and then I put the CEU inside of I gotta share my other screen. 1 second. Okay. Yeah, the CEU. If you go inside your manual over here on the left, sure it's showing. On the left, and you go either to files and download cpehunt.pdf. Excuse me. It's also in the chapters under conclusion down there at the bottom. And then again, yeah, the easiest way is just in files, and then everything else that all the other files we have saved are in there as well if you would like them. We got about 10 minutes before the 30-minute check-in. So we'll go do another 10 minutes and see how everyone's doing. Probably demo some stuff. I don't think we're going to get to the reporting piece of the lab, but you have an additional hour if you want to get to the report. I mean, we still have almost 2 hours left, or about 40 minutes left. But yeah, there's an additional hour on the lab after the cutoff time, so you guys can run through those if you would like to. Yeah, we'll do say about 10 more minutes and check in, see how everyone's doing. If anyone has any problems, please let us know. All right. Hey there, everybody. Everybody getting through it all right? Getting to let's see which ones we have on here. Everybody getting through everything okay, and when running into any issues or not having logs populate like they think. See, no issues. That's good. Good, good, good. All right, cool. Well, if everybody's good, has everybody gotten to registry events yet? Or kind of where, trying to see where everyone's at. Unanswered questions. Look at that. Perfect. Okay, great. Well, what I think we'll do then is maybe, seems like everyone is getting along pretty good. I don't want to demo anything before people have gotten to it. I'll do, say probably 5 more minutes, and then I'll go over the hunt, and then um, I'll go over the hunt, and then I'll wrap up the last like 4 or 5 slides we have on reporting. I won't go through the reporting bit um, in the lab. You guys can do that afterwards if you would like to, and then we'll wrap up from there. Yeah. So see everybody in about 5 minutes or so. Alrighty. All right. So I'm gonna go ahead now and just kind of walk through. I know that we walked through it in the in the lab manual itself, but just kind of walk through and hit on some points that I think are really interesting. And if anybody else has any other tidbits or points or interesting things that they had found, I'd also be very curious to hear that. So in there initially, again, we've gotten an alert. Hark, an alert. Hark is something that my mom always said, so I included that for her. But yeah, hark, an alert. So you've received an alert from the SOC. Your Windows event logs have been cleared on the unicorn box. Oh no, not good. But thankfully, we are ingesting everything into our SIEM already, so it doesn't matter that they cleared the logs on the box itself because all of our logs are ingested in our SIEM, or at least that's what we think. So we'll go ahead and start. You can see, you want to start with what you know, right? So what we know is that the SOC received an alert that the event logs have been cleared. To view event logs that have been cleared, that's in your security event log, event code 1102, right? So we go in there, we just confirm that we see the same thing that they see, right? So we have in there just by looking at 1102, time ticker set to 4 hours right now, that's fine. We go in, we see that it happened, we can see what machine it's on, this unicorn host, the security log, trying to see which log has been cleared. Security, status, got the tag on there. Maybe it doesn't say which log has been cleared, but it says on there that we, right here, logging security. But we see in there that our event logs have been cleared, so we know, okay, cool. They see the same thing or we see the same thing that they see. Let's look some more into it and see what else is going on. So in there, like I said, we want to expand the time range. We know our initial indicator here. We want to expand our time range to just kind of be, or not expand, but bring in our time range to just show events around this time period. So to do that, you can click on the time here, and then we'll just do 30 seconds just to kind of see what is happening right around it. This time is going to change based off of your environment and how much stuff you see, how many machines you have in your environment, logs you're ingesting, things like that. So the 30 seconds might or might not be enough time. Stat, even though we changed the time, we still only see that event log. That's because we have that set in our query up at the top. So we'll expand that out to just Sysmon operational. We just want to see what else is going on. So we got 343 events. Can't really see anything with that. So what we'll do is we will paste this command in there, which is essentially the same thing, but we want to just focus on the event codes or on process creation of event codes. I think that's the best place to start because it's normally got some pretty damning evidence in there with whether or not with what's happening on the endpoint, right? So event code 1, and then we'll organize it a little bit just with stats and table. So again, seeing that parent image, and the values of those command line arguments. Here, see some more info. Got a bunch of Splunk stuff up there. That's what I was talking about with excluding things from your rules as you go on. Splunk, MS Edge, Google, stuff like that makes a ton of traffic. So you might want to exclude those. They could also run things under the guise of these applications. So it's a little bit of a what your risk threshold is. But in there, we got a bunch of stuff. We can see CMD being run, that H1 as a parent image. We see some command line arguments in there. Pretty strange, but let's clean it up a little bit. So down here at the bottom, point out that you could just add in to exclude the parent image of Splunk just to make it a little easier to see. So we'll go in, we'll exclude that. Much easier and simpler to see. I don't have let me refresh my window, see if my thing will expand the rest of the way. Okay, so a little bit easier to see here. But we can see, what are we seeing here? See the parent command line, we see h1.exe, h1, we see it clearing the security log, we see who am I, net time of localhost, which is from our, that's a little bit of a gameism, of a labism, because that was from our previous campaign we ran. But we see that h1.exe is the parent image that eventually cleared the security log. So we probably want to focus in on h1.exe and see what else it did, right? What else was it able to do? So at the bottom of the manual on all of them, we have the what do we know? It's a little drop down. So that'll go over what you should have seen from this page. And on to the next one. So we know h1.exe, probably something that needs to be investigated. So we have as a note, security log, all of our notes are in that what do we know? That'll be our notes for now, right? So we know that the event log was cleared, the security event log was cleared. We know it was cleared by h1.exe. What else is h1.exe doing? So in there, we take this query here. Excuse me. We take that query there, and we look at inside of Sysmon. We want the parent image or the image of h1.exe. And we want to know what event code it is and what task category it is. And then that's going to be the count. That's what I was talking about before, that numerical value. So we see there's 101 events inside file create, 30 inside network connection, and 3 inside process create. Jacqueline had pointed out that she wasn't seeing everything from inside of here before. I did the same thing when I ran it. I forgot you need to, I think I wrote it in here too. I just totally skipped over it. Make sure you set that time picker to something bigger, right? Because all of these events didn't happen in a 30-second time span. So now that we are able to focus in on h1.exe, we can expand the timeout a little bit and ideally not have a ton of superfluous logs, right? So in there, we could see, does this match up? Process creation, network connection, made some files, did some DNS queries, and loaded some images. So we see that it existed in some spaces here. The DNS query, that's pretty normal, right, for really any process. But 25 process creations is pretty strange. Creating 205 files, that's pretty strange. And changing the registry value over 1,000 times, that's pretty weird, right? So we have those documented. We have over here just like why we should hunt on them a little more jump off. And then into what we know, again, security log, h1.exe is the parent process of that, and this is where else it exists. So the next one, now we'll focus in on process creations. So we're going to start iteratively going through each of these event codes to see what h1.exe did inside of each of these codes. So the first one up is event code 1, process creation. Again, that's my favorite place to start. See a bunch of info. I don't want to see all this. I want to see it grouped. So in here, I want to see just what command line arguments were ran by this image, right? So we see h1.exe. We have a whole bunch. We have ARP, deleting shadow copies. Looks like trying to curl up that exfil.zip to transfer.sh, IP information, compressing some files. We see lockbit v3 here. Would a threat actor be so brazen and bold to put their own name as the directory? Yes, they would. So by the time they get to this point, it might be too late to stop them. So they don't really care at that point if you know who they are. We can see Notepad spawn this readme.txt that should have popped up for everybody at some point. You might have just closed out of it after you saw the pop-up. And then we see the clearing of the security log and then attempting to clear all of the logs that you have. And then we also see this interesting point here that H1, this is why we have it both as the parent image and image, is in case something else spawned it or something happened beforehand. Oh, sorry. So we have here that h1.exe was spawned by Explorer. Does anyone know why it says that? Some of yours might look a little different depending on how you did it. I wish that the Zoom chat would have like the 3 dots, like when you're texting someone to see if anyone is writing something. But on there, it tell you Explorer.exe is the parent image because Explorer.exe is what spawned this. Explorer.exe is your file explorer here. So this proves that somebody clicked this to run it, right? It didn't run on its own. It wasn't spawned by PowerShell. It wasn't a command line argument. This means that somebody opened up File Explorer, either double clicked on it or right clicked, ran as administrator. That's what this proves. So this proves some kind of user interaction. Maybe somebody was tricked. Maybe somebody is inside a threat. I don't know, but somebody clicked it. It wasn't like a drive-by download that immediately executed or a USB that was plugged in that executed it. Somebody clicked on it. In there, see the parent and parent image. This one we'll expand the query out a little bit to show parent image. So again, pretty much the same thing, just having it broken down by image. So maybe if it spawned another executable or something like that, we would be able to see it. But from here, I prefer the other view of just this one. We see some pretty telling signs, like I said, of malicious or adversary behavior. You know, the shadow copies being deleted, that's probably pretty abnormal. This transfer.sh, which again is very similar to that file.io we saw when I was going through it on the slides. And it's called exfil.zip. Maybe that's a little bit obvious, but command line curling to upload a file to a public hosted file transfer website probably should be investigated, right? We see the lockbit v3, clearing of the security event logs. So lots of information in here. We have them all written down. We have h1 was the parent image of all of these commands. So again, just documenting as we go, making sure that we cover everything, you know, as it comes up. And on to the next one. So we looked at process creation. Now we're going to switch over to file creations. Again, this is from that initial list where we listed out all of the event codes by the parent image or image of h1.exe. So in here, first up, let's go ahead and copy paste. We'll see what files did it create. And it made a lot of files. Can anyone tell me what this .lockbit at the end of the file is indicative of? And then these, well, you guys are encrypted file by lockbit. That's perfect, Russell. Russell, that's what I'm talking about. But yeah, if you see a normal file name and then a .lockbit or .random characters or $$ something, that is indicative that it has probably been encrypted and is a part of a ransomware campaign because they append something to the end of the file. So that should be a big point out. Like if this was your trigger, I mean, if you get ransomware and you see this, it's already happened. But that's a great indication that there is a ransomware campaign happening in your environment, on your endpoint, on your machines. And then another point to this one is these PS script policy. These are very interesting. So this is created by when attempting to run a PowerShell command or run a PowerShell script. So we run unmanaged PowerShell in this campaign at some points in time. So before it runs PowerShell scripts, it will create this file. This is literally a test, just like it says. It's PowerShell testing to see if it's constrained, if it's allowed to run, what the execution policy is, things like that. So there's not too much else you can gather from this. Like you can't trace this to see exactly what it tried to run, but seeing this PS script policy test is indicative that PowerShell is being ran. So that's again focusing on those state-based behaviors instead of just some command line arguments. If you see this PS script policy test and then everything else is kind of random afterwards, if you see that being run and you can't correlate it to PowerShell activity like at the same time, that's indicative that there's some kind of unmanaged PowerShell where it's running PowerShell outside of PowerShell.exe. So something just to be aware of. We have in here why a threat actor would do this. Again, is to encrypt the files. We could also see this readme.txt, which again should have popped up on everyone's machine. If you're asking why there are two of them, like duplicates for these, it's because in the threat itself, inside of h1.exe, we don't want to actually encrypt anyone's files. So we create the lockbit v3 folder, and then we put 100 files in there called this, and those are the files that we encrypt. So that's why there's double in there. In real life, you would just see the .lockbit, but we have to create the files because we don't want to encrypt actual endpoints, right? This is supposed to be safe. So we see these file creations, and then speaking of file creations, we were just tipped off by one of our end users that a ransomware note has appeared on their screens, and all of their files seem to be encrypted. So all of this again aligns to outside of the obvious .lockbit and the lockbit v3 directory, which is akin to what this threat actor does. Ransomware actors are very brazen. They want you to know it's them because they're trying to get paid, right? So in addition to that, now we have the ransomware note. We see that the files are encrypted. We know that ransomware has occurred on this endpoint. So what do you do with that kind of outside of the threat hunt? kind of at the same time running in parallel. You know this, like you've confirmed ransomware activity. That needs to be alerted before you get to the end of your hunt, right? This needs to be alerted immediately because ransomware can happen fast, smash and grab across all of your endpoints. You need to let somebody know right now. So that's what we do in this situation. We're letting everybody know, and then we ask our intelligence team if you have one. If you don't have one, I'm sure that somebody is responsible as a tertiary duty or something to provide this information. But you probably want to look up Lockbit ransomware, that threat actor, see what they're doing, see if there's other indicators that you can have kind of while you're continuing your threat hunt, have somebody else try to pull up these indicators or queries or things like that to be able to see what else they did, get a little bit of a head start on it now that you know who you're dealing with, right? And then we know there from the what we know, again, we just added that the ransomware node has popped up and that it's created this directory. The files in this directory are encrypted. All right, then from that, we'll move on to the registry events. So in the registry events, we'll go ahead and grab this. There's 3 different places it could exist, 12, 13, and 14 for the event IDs. So that's going to be object created or deleted, the value being set, and or renaming the values. So you see in here, we're looking for image of H1 in 12, 13, or 14. See, so in here, if you guys have seen, you can see it as I'm scrolling through. What are they trying to do here, right? Why are they going into? They all seem to basically. Oh, that's too much. Seem to basically go to the same route, and then it's after the channels that they're looking in enabled for a lot of them. What do you guys think that they're doing? That they're doing there? Yep, 100%. So in there, you see I added in, if you go down to the bottom, so in our initial search, it has just the objects that they were trying to manipulate. If you add details to the fields that are pulling out of it, you can see what they're setting the value to. So just like Russell said, they're disabling log writing via the registry. So going in here, they're going into win event channels, AMSI, debug enabled, analytics, real-time monitoring, et cetera, all the way down. And they're setting that from enabled to 0, which will disable them. This is what happens so we do this via upshell, that unmanaged PowerShell I was talking about. So we're not going to see the command line arguments of us doing this. But again, by focusing on state-based changes, for them to disable it, it has to be set in the registry here. There's no way around that. They could delete it, but deleting it will still create a log. And deleting it isn't the same as disabling it. But so we know in here that now they've gone in, they've attempted to disable how many? We got 1,000 events. So let's say 1,000 different event registry values they've attempted to disable. And then I believe if I scroll all the way down, that they have enabled some. They've enabled disable anti-spyware and disable real-time monitoring. So essentially the same thing, right? They are trying to disrupt the security controls, defensive controls that you have on the endpoint to not, to kind of lay the groundwork for them to do malicious actions after this, right? So again, on this one, focusing on state-based detections, it has to be set here so it's a higher fidelity detection or rule by focusing on the registry events, as opposed to just looking for like set dash item property or whatever inside of PowerShell or command line, or searching for like HKLM or anything like that. This is a better way to do it because it cannot easily be changed. And then brings us again to what we know. I wasn't going to copy paste 1,000 registry files, so in your notes you probably do actually want them, but it's just too much for that slide. All right, so we see the registry values that it has manipulated. We have an idea as to why they would do that. So now we'll pivot over to network connections. Like we say up here, we don't have a network monitoring tool, network security monitor inside of our lab. We just have the host-based labs or the host-based logs, but that's fine because we're still able to log network connections via host logs. So first one up, we'll look in event code 3. Thought I had one that did both at the same time. Yeah, I'm just gonna run this one because it doesn't both at the same time. So here we'll look in event code 3 or 22, which 3 is network connections and 22 is query name. So DNS connections going out. We can see that h1.exe attempted to resolve anonfiles.com, SCYTHE.local, and premiumize.com, and our two destination IPs over here. So what does that mean from the anon files and premiumize? If you Google those after, you could see that they are like file hosting websites. So likely that they would attempt to either exfil some files out there, or that they would host additional payloads out there that they would then try to download, or they're a part of the C2 in some form or fashion, right? SCYTHE.local is literally our SCYTHE.local account here. That is our C2. But in real world, it wouldn't be that obvious, right? But here we see who they're connecting to. So again, you want to take this information and pass it out either to your firewall team or to other defenders and be like, hey, do you see this in the firewall logs? Are these being blocked? Or any other host doing this? Things like that. You want to now start, now that you know that something bad's going on, you know that ransomware is going on, you want to spread this kind of as fast as you get it and see what other machines it's affecting. All right, and that's our very, very quick hunt through it. But with that, this is like I'll say like a triage hunt, right? We're getting all the information, we're getting everything in there, we're trying to figure out what's going on, if it needs to be escalated, everything like that. But there are some unanswered questions that we have here. So with that, we don't see process creations for the files being created, encrypted, or the registries being modified. I feel like I answered this on accident already. But the reason for that is, again, because if we ran those via either Windows API calls or Upshell, which is unmanaged PowerShell. So those aren't logged in a traditional sense as these other process creations, so it doesn't see it. Again, just to focus, or just to highlight those state-based detections, and just to make sure that you don't try not to pigeonhole yourself into looking at one thing. See kind of like from a 1,000-foot view, what else is going on, right? It's easy to get. Say it's easy. It's almost guaranteed to happen that you're going to get pigeonholed on something, but you need to make sure just to take a step back, have another set of eyes. Take a walk and come back and kind of ask yourself these questions. Why don't I see these? And then try to figure out why. And then the next one, we don't see we saw in the process creation that it reaches out to, it's either file.io or transfer.sh. Transfer.sh. We see that in that statement, in that process creation, we see the command line argument of it reaching out to that website. Anyone have any ideas why we don't see a DNS request for transfer.sh? The reason that we don't see a DNS request to transfer.sh from h1.exe is because h1.exe did not make the DNS request. Curl did. So curl is its own binary inside of system 32. So when h1.exe is giving the command line argument of curl to reach out to transfer.sh, what's actually happening is h1.exe will spawn curl, and then curl will do that command line argument. So that's why we don't see h1.exe reaching out to it, why we only see curl.exe reaching out to it. Again, just you want to see everything, not everything, but it's good to take a step back, make sure that your net is wide enough, that you're starting wide enough to capture all of this information. And an important part of why you have notes, maybe star something that you missed, you're like, I know that it reached out to transfer.sh. I can see it in the command line logs, in the process creation logs via the command line. Why don't I see it somewhere else? And this is why. All right. And then, yeah, just some things to consider that we pretty much already talked about it. But pull the hash of H1, see if it's on other endpoints. Try to produce some IPS or detection rules to try to stop the observed activity that's happening from happening even further. And final kind of reflection of this hunt, is there anything that wasn't investigated that you think is important? Any assumptions you need to verify? Additional logging that's needed? Anything like that? This will treat the final reflection kind of as our refined time, to go in there and update the logs, update the detections, all kinds of stuff like that. The time to do it now that our hunt is over, to go back and review it and make sure that everything is everything is up to date, everything is as good as it can be, right? Are there any questions on the hunt piece? Alrighty, then I will just quickly go through the reporting slides, and then that'll be it for us. So go through. So reporting, try to do this in under 5 minutes. Reporting, what do you know? Who needs to know? And have I told them? That's from Secretary Mattis, General Mattis Chaos himself. Little reporting soapbox. Without reporting and dissemination of your findings, there is no long-standing effective change. The most important part, which I know it probably doesn't seem like it because I skipped over it, because we're going to skip over it, but the most important part of threat hunting outside of finding the adversary is reporting and dissemination. If you are not able to accurately write up what happened, why it's important, and what to do in the future, and that doesn't go out to everybody that needs to have it, the same thing is just going to happen again, right? Reporting is crucial. Details, be thorough, be specific, anticipate what people are going to ask you and answer that in your report. So some ways to do that. The MITRE ATT&CK Navigator, you have the link down there at the bottom. Just a great way to visualize it. So as you observe TTPs, you can mark them off right there on the attack navigator. It's a great visualization of everything that's happening in your environment. Or not in your environment, excuse me, everything that was happening in your investigation. Next up is the MITRE ATT&CK flow. Is the way to literally map out and visualize exactly what the adversary is doing. So you can have command line arguments, any sticks or taxi verbiage, command line arguments, files being created, network connections, things like that. All of that you can write up via the MITRE ATT&CK flow. And then the intrusion analysis template. This is just a way to write up all of your info and download it, disseminate it to whomever needs it. I will take just a second and show that. So in the lab, it's got exactly how to do this. You guys can do this on your own for the next hour or so if you would like to, but they have the 4 different blueprints you can utilize: threat actor profile, campaign, executive report, and intrusion analysis report. Ours would be an intrusion analysis report. And let's go through. You can plug all this information in. It prompts you for questions or for information, which I think is very helpful. And again, in the lab, we have like places with this that you can put in all of this info. We also have this one you could just download and upload it into it. But it's very useful. Indicator analysis, TTPs likely in the network or observed, different indicators, intel requirements. It has gaps in here, what threat actor is doing it, artifacts, all kinds of stuff. It's really great. If you don't have a intrusion reporting template already, I would highly recommend using this one. Yeah, I said I won't get too much into that because I know we're already a little over time. And then just some tips for hunting through the SIEM. Start with a wide net. Like I said, start wide, and then focus in on specific events as you see them. Right, it's better to start wide, pick out, oh, these 10 things are weird, then investigate them on their own, then hyper focus on one event, and then you miss the 9 other events. Again, taking notes as often as you can. be difficult when you're in the middle of it, performing actual incident response. That could be very difficult. So screenshots and a quick one-liner are great. That'll be enough for you to go back, remember what you were doing. You're not going to remember command line arguments or IP addresses or anything like that once you start threat hunting on a real incident, because there's too much information. So screenshots, OneNotes, one-liners, get that info in there. Again, anticipate questions and provide answers. Think of what people are going to ask you and answer it on your own. And that way, that's both in threat hunting and when you give the report. When I give a report, I don't want people to ask me really any questions about it. I want to have the report and have so much information in there that anyone can read it without any prior context and understand what's happening and why it's important. You want your reports to be detailed. You can always put in additional appendices, screenshots, executive summaries, all kinds of stuff, but your report should speak for itself. And then yeah, hunt as often as you can. That's really the best way to do it is to do it, right? I mean, the best way to get better is just to do it. The more you threat hunt, the more you'll know your environment, the faster you'll find anomalous activity, or you'll be able to disprove anomalous activity. Your detections are going to be better. Just do it as often as you can, right? Threat hunting is super fun. It's like the most fun job you could have. Just hunt as often as you possibly can. And then yeah, thanks everyone for hopping on this workshop. We do workshops every month, not always blue team based, but sometimes red team, CTI. We have a whole workshop just on Sigma that's 3 hours long. So yeah, hope to see everybody in the future if you want to come back. And then a little promo here, do Purple for Good. If you want to get a sweet unicorn tee or hat or anything like that, we have swag.scythe.io. All the proceeds from this go to charity for real life unicorns, as we call them, chubby unicorns to rhinos. So it's a great cause. If you would like a shirt or anything like that, that's where it is. And then yeah, with all of that has been hunting through the SIEM. I'm still Tyler Casey. That's still Trey Bilbrey. If anybody has any questions or comments or wants to connect or see anything more about SCYTHE or anything like that, please reach out to us. The recording should be on our YouTube, just SCYTHE_IO here in a few days. And yeah, if anybody has anything come up before then or at any time, please feel free to reach out to us. Greg?
All good. Thanks for participating, everybody.
Thanks, everybody. Yep, so that lab will be open for about another 54 minutes. So yeah, you're free to do whatever you want with it. Oh, hold on, I do see more workshops on the website. Is there another one that builds off of this one? I would say if you like we're working on doing a more advanced part of hunting through the SIEM. Eventually, it's not done yet, but I would say if you have one that you want that kind of builds off of this, I think probably the Sigma one. I said it's a 3-hour workshop where I just talk about Sigma rules, how to create them, how to use them, how to all kinds of stuff. We get very in depth on it.
It's a big dive into detection engineering.
Yes, yeah, we have a detection engineering workshop. We do every couple months, power to the purple. But I would say, yeah, the one that builds off this is probably Sigma. And then whenever we get that more advanced hunting through the SIEM, ideally here in a few months. But yeah, just keep a lookout on that. But yeah, thanks everybody for hopping on. I'm gonna unshare. I'll be on for a couple more minutes in case there's any last minute questions. Yeah, thanks everyone for hopping on. Hope to see you again.